Hello, everyone. Well, thank you so much for being here. It's amazing to see so many of you joining today at the last session of DefCamp. It's amazing. Really, thank you so much. It's been an amazing journey today. So far, we learned so many great things, have some amazing presentation, including those of my colleagues. But I know there are the CTF rewards after that, so let's move on. My name is Morosan Ionut. I'm a mobile security penetration tester for over 5 years now, and I'm working at KPMG, being their mobile security expert. I have a bunch of certification, mostly from Ionut Security, and I'm also the founder of TravelSec. I do enjoy the work-life balance, so that's why, alongside my girlfriend, we started a travel company where we are sharing our work experience and traveling. So if you want to learn more, you can go on Dynamite and find us about that. What we are going to do today, we are starting with a brief of introduction. We're going to see what is MMSF and how it came to life, let's say. We'll see its features, its usage, and we will focus more on the demo part. The mobile security field is very challenging and most of the time overwhelming, with lots of tools and methodology that you need to know to perform the job very well. But what if I told you that it's not that hard? Well, yeah, you need to jungle a lot of, different tools like Frida, objection, Drowser, and so on. And you have to know, jumping from different terminals to another. And with time, it becomes tedious. So I'm talking about tools, but what are the most used tools? The most used tools are, of course, Frida, which is used for dynamic instrumentation. And it serves as a base for objection or grapefruit, and many other tools. What do we have for static analysis? For static analysis, we do have JEDIX, we have MMSF, we have APK tool. We have a lot of different tools, but how do we integrate those tools? Is there any way to work with all of those tools together? Well, I start to think about the solution. So I start to think about writing different bash scripts for different, like scanning with multiple Drowser commands, pulling an APK from the device if I don't know the application's name or things like that. But even if I wrote those scripts, I was starting to forget the syntax most of the time because you are not doing mobile pen tests full time. You are doing from time to time, so you start to forget syntax. So this became tedious again, and it was frustrating for me. So I needed a way to centralize those tools into one simple formula that can help me do the job very well. How many of you have ever heard or used MMSF before? Okay, quite a few hands, great. For those who does not heard about it, it's a massive mobile security framework that combines almost all the existing mobile tools into one big framework, similar to what Metasploit is today. It works very well with both iOS and Android, and it's constructed in a way that it has different modules and submodules for different methodologies or exploits. So you don't have to rewrite everything just to add a new exploit or anything like that. It leverages the power of Frida, Drowser, objection, to help you focusing more on finding vulnerabilities rather than, starting to understand how tools are working and so on. Okay, let's see what are its main functionalities and how this tool differs from the other already existing tools. With MMSF, you can easily bypass jailbreak detection and SSL pinning. You can easily bypass the biometrics if it's somehow misconfigured. You can easily run scanning modules using both nuclei or Drowser. You can handle the APKs, both split or normal APKs, like pulling the APK from the device, generating, patching, signing, and so on. And you can also exploit deep links. You can exploit exported activities. You can exploit broadcast receivers or content providers. It does everything for you. But this tool is not a magic tool that can do everything for you. It has its own limitations. Mostly comes from the usage of RASPs, runtime application self-protection. If the application uses such technology, this tool is basically useless because the way RASPs work, it performs a lot of checks at different points of time, so only running this tool would not help. You would have to manually do this. And if you manage somehow to bypass the RASP, you can even create a module for that to help you do that in the future. Another limitation is done by the fact that I'm relying on external dependencies, Frida, Drowser, Objection, and I'm not in control of that. So in the world that it's changing over and over again with tools appearing overnight and disappearing, it's very difficult to keep up with those. So in case something is changing with those tools, my tool would also be affected. Well, let's see how you can use this tool. It's very simple. You just go to the GitHub and clone it. It's open source. And you have to forget about installing manually Frida, Drowser, Objection, Java, Nuclei, and so on. You just have to run MMSF update.py. That tiny script would install everything for you. Would install all the prerequisites and make sure that everything is set up for you to start pen testing. Now, once you have all this installed, it would take some time. You just simply run MMSF, and that's it. You are now in the interface where you can list modules, use modules, set everything, and just hit run, and boom, the exploit is done. Let's see it in real life. We just hit MMSF and validates if everything is installed. Looks like Drowser is not installed on the device. It magically installs the Drowser, starts the embedded server, and that's it. Now I'm in the interface and I can use module, list modules, and so on. Pretty cool, right? And now it's the fun time, and specifically showtime. I make this workshop in the idea of 3 different scenarios. One scenario would be to execute static analysis audit on a published Android application. Another scenario would be a dynamic analysis of this application, and we will end up with a full pen test on an unpublished iOS application. Let's start with the first scenario, which says that you are being tasked with conducting a security assessment of a newly released Android application called Enigma Bank. The app, while seemingly innocuous, has raised some security concerns. Your goal is to identify any security vulnerabilities within the app using static analysis to assess its overall security. But how do we do that? My methodology here is very simple. I will start with the find module to see what is its package name, because I don't know it. I'm pulling the APK from the device, I'm decompiling it, and then I will start the scanning with two different modules, the one with Drowser and the one with Nuclei. So let's start with the beginning. Let's find the application's package name. It's very simple. I only know that the application is called Enigma Bank. It's running on a rooted device, so we will handle that later. Let's use the find module now. We'll use find, and we will set here the required parameter, which is filter. We set the filter to Enigma Bank, and let's see if we were able to find something. I'm printing all the commands here in case the tool does not show any result. It might be some interference or some glitches, and you can simply just copy and paste the command. It looks like we were able to find the application's package name. Great. Now let's move on and pull the APK from the device. I don't know if the application is a split application, an app bundle, or a simple APK, so I'm using split APK just to be sure that I'm pulling everything related to the application from the device. I'm using the pull module. Does it work? Yeah, it works. Or it does not. Looks like the video are not playing. Oh, but yeah, it's working. We've just moved to the decompile part. I'm using the split APK module decompile, where the previous the APK was stored there, and I'm only setting the path. I've extracted the APKs. Let's see if already decompiled the APKs. It successfully decompiled the application that I retrieved earlier. We see its content here. Okay. We have set everything. We've got the APK, we've decompiled it, so let's just now scan the application using the scan module, which is basically a collection of all the Drowser commands used for scanning. I do need to set the output directory where the scans should be saved and the application name. Let's set the directory here. And again, the application name. And let's just let the scan run. And you can see it performs all the scans regarding everything that Drowser does for you. It scans for permissions, for broadcast receivers, for exported internet providers, and everything you would need to know in order to perform the dynamic analysis of the application. So let's check if any deep links are exported. And we can see we have a deep link here that might be used next to exploit the application. Let's see what activities are exported. We can see there are two of them. One specifically targeting the web view. It's another entry point. Let's see what is the attack surface draws are shown us. We have 2 exported activities and 1 broadcast receiver, which would not exploit it. And you can also have the manifest file here. OK, let's use the nuclei module now, which uses, of course, nuclei templates to show you some interesting information about API keys or any vulnerability that might help you in the dynamic analysis part. Let's set the directory name where the decompiled application is stored, so we can run the scripts in the background. And while those scripts are running, we can perform anything else. But let's see what are the results from nuclei. We see a lot of issues that might trigger an alert for a dynamic analysis regarding the web view. And we are still waiting for the results of the APIs. No API keys found on the application. You can also check the results in the saved directory. So that would be the static analysis part. Let's move on to the dynamic analysis of this application. You are tasked with performing the dynamic analysis of the previous application. What is the methodology that I'm using? I'm trying to see if the application is running on a rooted device or not. If so, I would try to bypass the root detection. I will try to bypass the SSL pinning of the application, and to intercept the traffic and see what's inside the network. I will try to exploit any exported deep links or activities, content providers, and so on. And lastly, I will try to bypass the biometric usage to access the victim's account. Let's start with the bypass of the root detection. We can see here that the application cannot run on a rooted device. So let's use the root detection module from Frida. I have used some scripts that I made. We are setting only the application name. And once we hit the run command, the application is reloading, and we are able to use the application on a rooted device. What about SSL pinning? Well, it's the same and mostly as easy as using this command, setting also only the application's name and running the script. It's that easy. Not always, but most of the time this will do the job. Let's see, I've already set the certificates in the device. I've already set the proxy to burp. Looks like we have here something that might be over the network, and we were able to intercept the traffic. We saw that during the static analysis we have deep links. The application is using deep links to communicate easier for the user. Reading the code, we see that it's waiting for a redir parameter that is loaded into the web view. But the most important thing here is that it uses some JavaScript interfaces. 4 of them exactly. So let's try to exploit this application to read the session, the user session stored in the victim's device. Let's first see if we are able to launch a deep link here with our malicious command. We are setting the deep link. The data URI is just the Enigma bank that we saw previously, and setting any host as the application does not validate the host. The most important part here is the redir parameter, which we can use to set any URL there. Hitting the run command, you can see you are redirected to the URL you specified there. Very interesting. But let's exploit that JavaScript interfaces that are exported and see if we can have the user session. Here I have to make some mentions. I started again. For the JavaScript interface part, you need to set multiple things like the JavaScript interface name, the deep link query, everything that you might need to know to exploit, to create two different malicious HTML files. Those malicious HTML files should be stored on your malicious server. One is for launching the deep link that we previously saw that it might be exploitable. And another file called steal.html, which is used to actually call the exported JavaScript interface. So this way, you chain multiple issues into big one issue that might help you access private files or things like that. I've restarted the video, and I will set everything just now into the JS interface module. I have to set, as I mentioned, the application name, the server, where the malicious files are loaded. I need to set also the scheme, which is Enigma Bank. I need to set the component that is vulnerable, that WebView component. I'm running a local server to store the malicious files. The package is the application name. I will show you how those two HTML files are looking after the exploit is performed. Because it's interesting to see how this can only be launched for now from Chrome. So you can send the victim a link that is open using Google Chrome. And if the victims open that link and it has this vulnerable application installed, you can just simply gain access to internal files or anything related to the JavaScript interfaces that are exported. So now I'm setting the deep link query. I'm setting the parameter that is vulnerable, the one that is called a redir. And I'm setting the JavaScript interface to the one used for user session. And now all I have to do is hit run, and it created me two different HTML files. Let's open the launch.html file from Google Chrome and see if our exploit worked and we receive a beacon, let's say, on the server from the application. Let's check our server, and indeed we receive something which looks like a base64 encoded data. Let's decode the data, and here we should see the user session, indeed. So that's the way you can just steal data if there is a vulnerable JavaScript interface. This is how launch.html looks like. It's the way Google Chrome handles deep links. And the steal.html is made in a way that you don't need to remember all those things. Just set the parameters and those files will be created for you. Next part is exploit the exported activities. We saw that there is an exported WebView activity. Let's see how we can exploit that. We saw the vulnerable WebView activity that is set specifically here. And what is waiting for an extra string called URL, which is then passed to the web view. Okay, let's use the intent module to launch the malicious intent. Everything what is done here can be done from a malicious application, so you can just type everything into a Java code, compile it into the application, and send the victim the application. But for any POC, this would be much more easier rather than writing the Android code from start to end. I need to set the extra string that the application is waiting for, and I'm launching the intent. You can see I already, again, tricked the victim to open my activity. The most interesting part is that biometrics can be bypassed. And it's something that most of the banks would not want to hear about. You can do that because most of the time there is only a crypto object that is passed when the fingerprint is used, but not used for encrypting or decrypting files. So this would be very easy to bypass by creating a fake crypto object. I don't even need to put a wrong fingerprint. The script just bypasses that check. And we can see that in the iOS part, it's easier than that to just bypass the biometric and have access to the victim's bank account. Great. Now let's start with the analysis of the iOS application. iOS, it's a little bit difficult with its security enhancements and features, but it's not always that hard to break some iOS applications. So let's see what's the task here. The task is to do a full penetration test against the iOS application. And what I do, I always try to have access of the application on a rooted jailbroken device, because I can intercept the traffic, I can do most of the things that I'm not able to do on a normal device. So this will be the first thing that I'm doing, and after that I will try to intercept the traffic. After all it's set up, I will try to, let's say, exploit any data in the user storage. Most of the application are storing sensitive data there. And finally, if a biometric is used, I'm trying to get access to the victim's account by bypassing that biometric. Let's start with the bypass of the jailbreak detection. The application, if I'm running on a rooted device, it says it cannot be run on a jailbroken device. Let's use the jailbroke detection module, set the application's name. Again, I'm using Frida, but objection can be also used. You can also use some application from Sileo, like Shadow, but I like to do it this way. And I'm just hit the run command. The application is now accessible on a jailbroken device. Let's bypass the SSL pinning, to see what traffic the application is sending to the backend server. I'm using the SSL pinning command. I've already set and installed the certification on the device. And I'm setting the application's name here, hit the run command, and I should start to see some requests after logging into the burp. Let's open burp, and yep, we just got some requests here. Now we have the jailbroken device, we intercepted the traffic. Let's see what juicy information are stored in a user defaults space, and if I somehow can bypass the PIN retries and the account lockout using this method. Let's first see what's inside the user defaults. I'm using the data storage module with the NS user default submodule. I'm setting only the application name. It also uses Frida in the backend with some scripts that I made. I'm retrieving the user defaults. Let's hit run and see. We have some interesting information like pin attempts equals 5. This means that after 5 requests, the application should block the account. Let's modify this value and try to add a higher number so I can, brute force the pin. I'm setting the key here and the value with 999, and let's run the application. Let's run now again the retrieve to see if the changes are saved into the user defaults. Setting the application name, hit run, and we can see that we are able to modify the user defaults. Perfect. Let's try to use the wrong pin like 7 or 8 times. Let's see if we're blocked. 1, 2, 3 times, 4 times now, 5th, 6 times. We're not blocked, which means our exploit worked. And let's use a valid pin. And with a valid pin, we should be able to access now the account. So basically, what we did was a brute force and a bypass of the user defaults data that is stored. Finally, let's exploit the biometrics. This can be done because the application is using the local authentication framework, which is the simplest one because it only returns true or false if a valid biometric voice is used or not. We can use Frida, change the value from false to true, and the application would allow us to do that. So in order to help you and not trying to find the perfect Frida script for that, you can just use this module. It's biometrics, Frida iOS, set only the application name, hit the run command, and now you can try to use the login with biometrics. You can press cancel, and voila, you are able to access the victim's account and perform some withdrawals. Pretty amazing, right? That easy to do. This framework itself is very powerful and would let you to exploit some mobile application issues even without having proper knowledge of how to do that. It has a wide range of vulnerabilities and methodologies, and it's using modules and submodules, and this is pretty amazing because you can always add modules and submodules with everything you want. You found pretty interesting issue lately, and you don't want to do the same over and over again. You just can simply create a module for this and use this as a starting point. What would be the main benefit of this tool? Well, the fact that it's open source and it's over there for you to use. And, always I'm welcoming developers and penetration testers to help me add more and more modules to make the life of a mobile penetration tester easier and not that hard. So I'm always welcoming you to add and contribute to the tool. Thank you so much.
Excellent. Thank you very much for the presentation. I guess seeing the high number of people in the room, this means a lot. So
Yeah.
let's take some questions.
Yes.
Yeah.
Thanks very much. That was really interesting. I see that you used Android and iOS emulators. Does your tool integrate with tools like ADB and IDB in order to test on a real device?
Yeah, I'm using a real device for the iOS, not the simulator.
Oh, I see.
Yeah, but it works on real devices also. Yep.
Hi.
Hi.
Thank you for the presentation and also for the extremely hard work you put into this. I hope so many people enjoying your product and who already seen it and worked with it. I just wanted to ask for someone new into mobile pen testing. Would it be good to start with this, or they should go to each other tool, see how it works, and then come back at this and, I don't know, use it to improve their work?
I've created this tool with this in mind, so any new person that is into mobile penetration testing don't have to scramble all the internet for information, just have all the methodology and all the possible exploits in one place. So I guess they should start with this, and if they don't understand something from this, then start to search for specific things. But I recommend starting with this one because it has everything into one place.
Okay, so on this note, have you ever considered about building up a sort of methodology based on this tool alone?
Yeah. I'm start thinking about that.
Okay, that's
Yeah.
awesome.
Yeah.
Looking forward to it.
Yeah, of course.
Hello, really
Okay.
nice presentation. That's what I
Thank you.
wanted to say. And I was wondering, because nowadays we see more and more developers, especially in small companies, but even in bigger ones, navigate towards platform agnostic development with tools such React Native or Flutter. And as we know, React Native doesn't really compile everything to native code, since it has JS bundles inside the app package. And I was wondering, how would maybe some module of this tool maybe help us with this problem, pen test it? And how do you see the future of mobile security in this case? Because as we know, as developers, we use tons of modules. We don't really know the source and the code quality for each of our modules. And how does this impact?
Well, yeah, as I said at the beginning, the world is very challenging, and this field is very challenging. But with Flutter, we have reflutter that allows you to intercept the traffic. But for the React Native, I don't have anything yet into the tool integrated. But there are tools out there that can decompile and understand a bit of how the code is working. But it's difficult to exploit it as a native one. So it will be harder for us, penetration tester, to break those applications, but not impossible.
Okay, thank you.
Okay, one over there.
Yeah, so a quick question. Do you have any convenient ways of downloading APKs from App Store and Play Store to a rooted device?
I don't have any way to do that. There are tools out there available for both iOS and Android that can do that, but you need an account, a Google or an Apple account. It's in plan, it's in the to-do list to add IPA installer, which downloads the IPA from the App Store using an App Store account, and also there are tools that downloads the APK from the Play Store. If you want, you can just create the module and integrate it with MMSF. Make a pull request, and I will just have a look at it.
Thank you.
Welcome.
Any other questions?
One here in front.
Okay, and one in the back.
Cool. Looks like I'm first.
Okay.
So I'm just wondering, is there any plan to maybe put a nice UI over the tool and sell it? Or, I don't know, do you want to keep it open source or potentially bring some sort of premium option to it?
For now, I'm trying to keep it as open source for everyone to use it, because this is how I started, with this in mind, to help new people to understand the mobile security and, you know, not make money out of it.
Right.
So I'm not having anything in plan for now.
Cool, fantastic. And just as a suggestion, I'd love to see a reporting module in there. So basically, just report the findings straight away, straight from the tool. But we can definitely talk about that a bit later.
Yeah. Might be something to work
Cheers.
on. Okay. Yep.
What would be a typical scenario for like using your tool to bypass the biometrics? Like for the attacker? Like how could I or some attacker use it to do some harm to the user?
You can connect with Frida to a remote server and just use the tool to connect to that server instead of USB. So if you are in the same network as the victim and you already, you know, served the victim somehow the Frida via the gadget or using another application, you can connect with this and just run the biometrics module as normal.
And for the Android one, does it need to be rooted, the device?
If you manage to send the victim a patched application with Frida gadget on it, it does not need to be on a rooted device. You can do it on a normal device.
Okay, thank you.
Yep, no problem.